Congratulations, test 6, end of the first semester. All right, what do we have? Sections from 4.7, 4.8, 4.9, 5.1, 5.2. Rather short test. I don't think one of the more difficult tests. I think it really just matters if you can factor right now, right? If you can factor quadratics, you'll be fine. Now, the formulation of the problem is important as well. So for a word problem, coming up with the actual quadratic that you'll use is really, really important. And you saw that with 4.8. With 4.9, you saw that actually knowing what to do with the quadratic inequality with critical points and regions is the part that's important. With 4.7, it's pretty much taking a function or an equation and setting it equal to 0, factoring, and solving.
Isn't it
Through 5.2, thank you. Because in my head, I'm like, 4 sections, so I added 4 to it. Yeah, we had 4 lessons. And then 5.1 and 5.2 we did together, and that was rules of exponents, which I think for the most part, most of you are pretty good at. If you find that you're having trouble with it, you just need to practice. You got to practice. And that doesn't necessarily mean just going on the textbook and doing problems. Sometimes practice means going home and watching a Khan Academy video separate from this, or a YouTube video on extra problems about rules of exponents. I guarantee you there are probably 1,000 videos on a search result, and there's probably even more than that, but 1,000 decent ones. This is one of the most commonly occurring math topics. Okay, rules of exponents. So advocate for yourself if you're struggling. We'll go over them again today, but there's only so many ways I can really explain rules of exponents, and what I tried to do yesterday was derive all the rules for you, show you where did they really come from, like a power to a power, or thinking about your addition rule. Well, if you write it all out, it actually makes sense, but you wouldn't write it all out. But when you forget on the test, or if you have a little brain fart, you need to think, picture it in your mind. What does it actually look like? What does x cubed times x to the 5th look like? And that's how you can come up with what the actual rule is, if you forget. Flashcards are very useful for the rules. Okay. What do you want to start with? I'm going to start with 4.7 examples of factoring, the ideas. I'm going to pull them out of here because I need to make them work so they're factorable, and I don't want to have a mess with them. George, do you want to pick something specific? You want to jump into word problems? Because it's factoring in the word problems anyway.
Also the 5.2 problems remove the numerator.
We have a fraction and negative exponents and all that. All right. So we're on 4.8. We'll start with then. Let me pull an example out that you guys have not done. Let me know. Remind me if you've done this example. I'm trying to think back on what your homework examples all were. Here's a common one that starts on all SATs, and we've done this one before. Something like it at least. Find 2 consecutive odd integers. You can type it or just listen. Find 2 consecutive odd integers, the sum of whose squares is 130. Did we do this?
All
right, how about this one? Find 2 consecutive odd integers whose product is 143. It might be similar. Did you do that exact one a minute ago?
I don't think so. Yeah.
For problem sets?
But this is not on the problem set.
Find 2, this might have been homework, this one. Find 2 consecutive odd integers whose product is 143. If the integers are odd, how much do they differ by? They differ by 2. So if I call the first one x, very good. Those are my 2 integers. Their product is 143. Product means multiplication. And then we have a quadratic. Distribute the x to both and move it over. We got x squared plus 2x minus 143 equals 0. What number is multiplied to 143? You got it?
So it's 13 and 11. But I said you did testing, so what is it?
Yeah. So that's what I was just going to say. Recognize with these problems with the odd integers, and when there's only 2 of them, that this is always this number here. Take a look, please. This is always going to be 2. Why? Why will that always be 2 for these kinds of problems? For any problem that says the product of 2 odd integers consecutively or 2 even consecutive integers, for any of those problems, that will always be 2. Yeah, isn't this always going to be here if they're consecutive odd and consecutive even? So that's always going to be a 2. So Kate said, you know what? Really, you could just do it by saying, what are the numbers that multiply to give you 143, right? Because in the end, that's what you're going to have to figure out anyway. So whether you just started the problem and saying, okay, what odd numbers multiply to this and differ by 2, that's really what you're doing right here. By figuring out what multiplies to this and ends up having a 2 here, you're figuring out what multiplies to this and differ by 2. So a problem like this on an SAT, jump right to the answer. Don't show all your work, obviously. Don't even use this quadratic like this. Just think what multiplies to 143? 11, 13? Is that what you guys say? So here we're going to get if we order fact. I'm going to go through it just to show the process of solving a quadratic. So it's plus 13 minus 11. How come it's plus 13? How come it's plus 13? Look.
Because it'd be negative 2 if it were minus 13 and plus 11.
Yeah, if this were the positive and this were the negative would be more, and thus the middle term would be negative. Whichever of these is more makes the actual value carry that sign. So if this were 15, then this would be a negative number here. Keep that in mind. I'm just trying to go over this because some of you are still struggling with some factoring stuff. Solutions-wise, we get 11 and negative 13. Now, that means that the other value we call y, or x plus 2, and that's going to give me 13 here. And if I add 2 to this one, it'll give me negative 11. So this is one of my pairs, and this is the other pair. That's the key, though. With factoring, you see that there's 2 answers. If you just said to yourself, well, what multiplies to 143 and differs by 2? You might just say 11 and 13 and stop. But don't forget about the negative 11 and negative 13. They differ by 2, and they sure do multiply to 143. No voice. It's killing me. Does that make sense? Yeah? All right. Isn't that a little harder then? Did you do number 14? I'll take a picture real quick so it's easier. But it says a rectangle is twice as long as it is wide. If the length is increased by 4 and the width is increased by 3, the new rectangle has an area of 100 centimeters. Find the dimensions of the original.
We did that one.
I don't know.
Are you sure? You're the only one that thinks we
We did a
did.
similar one.
Which section is this?
All right, well, if you did a similar one, the numbers are just going to change, so I'll try it. Well, you tell me which one you guys want to do, actually.
No, we did number 15 and 48.
You should sign those over.
Thanks, George. I'll keep that in mind. That's good. I give you guys very little homework, I think. I used to give a lot more homework in this class when I taught it 3 years ago, and I've really decreased the amount of homework I've given. And honestly, for that reason, oh, Jesus. Really? For the same reason you just said, because sometimes it would just become a bit much and redundant after a while. But you guys don't get that much homework. I used to get a ton more homework. I don't know what it is. When I was a kid, teachers always thought that it just meant give more homework and it made it a better class or make kids learn more. It's not always about quantity. All right, which one do you want to work on? The one I read was 14, but if you want to do a different one, you can do a harder one. You want to try 14 to start? 14 is not that bad. Start with a rectangle. It says it's twice as long as it is wide. That's the key here. We have to take that statement and translate. Twice as long. So is the length bigger or the width bigger? Which one? The length. If it's twice as long as it is wide, it means that the length is twice the width. So we've got this here. Okay? Agreed? I hope. It says next, if the length is increased by 4, so go ahead and do this, please. Tack on the plus 4 here and here. And the width is decreased by 3. The new rectangle has an area of 100. So that's all it becomes. What's the formula for area? Length times width. Your length is 2w plus 4. Your width is w minus 3. And the new area of that is 100. Why would this be a little bit lengthy of a problem? Don't even solve it, guys. We can solve this after. Why would this be a lengthy problem? Or? Good. So if you do the AC method, it could be I said could be a lengthy problem. It could be a very lengthy problem. What should you do? You should not use AC method here. When you multiply this out, you're going to get 2w squared. In the middle, you're going to get negative 6w plus 4w, and then minus 12 equals 100. If I collect terms, what do I recognize right away? What do I recognize right away?
Minus 2.
W's don't cancel. They collect, yeah. But what do you notice is happening? Yeah.
You can divide by 2.
Yes, please. Please. Oh, this is number 14. Please don't go ahead and try to use AC method here. Factor GCFs out whenever possible. First step of all factoring techniques is always GCF. Take out that 2. What times what gives you 56? 7 and 8. It's not a coincidence. Which way? Bridge, which way?
Plus 7 minus
Because the middle term has to be negative. You made the 8 negative. Very good. Okay, giving us answers of negative 7 and positive 8. Which answer is it, everybody?
8. Positive 8.
Oh, come on, that wasn't everybody. Yeah, you can't use a negative answer. Why?
Because you can't have
A negative.
You can't have a negative length. You can't have a negative length. And here's the thing. I changed to X. I apologize. It should say W. Here's the other thing to recognize. The original rectangle, its width was W. So if you get a negative answer, it's automatically refuted. But technically speaking, you should test these numbers in the new dimensions to see if it makes those negative. Because what if this said, ready? Follow me, please. What if this said W plus 9 and your answer was negative 7? Wouldn't this still be positive? Because negative 7 plus 9 would give you 2, really. And if this were, well, let's see, here it's not going to work, but hypothetically, what if this were like a plus 20? It's not going to happen, right? But I'm just saying theoretically, you need to test it in these dimensions to make sure that the dimensions actually turn out to be positive, not the original. In our case, though, the original was W by 2W, so it also would make those not possible. So W equals 8. So what does the question say? Find the dimensions of the original rectangle. So what are the dimensions of the original rectangle?
W and 2W.
W and twice that. So 8 by 16. We all see that? The answer asks about the original rectangle. What if it said find the dimensions of the new rectangle? What do we got? Come on.
Add 4 to the second value and subtract 3.
So you're doubling and adding 4, so you got 20 there, and subtracting 3, which is 5. So, Tristan, I agree. Why would you go back here? Just take away 3 from this, that's what we did, and add 4 to this. That's what was happening, right? Take away 3, add 4. Very good. Don't even plug the W back in up here. Just take the old dimensions and operate on them. Much faster. Very good. All right, another one of these. Can I copy this photo? Is that possible? No? That's annoying. Another one. Which one? Yeah. 16? A ball, oh, this is great. A ball is thrown directly upward from ground level with an initial speed of 80 feet per second. How high will it go and when will it return? How high will it go and when will it return? So for a problem like this, we have to think, what are we trying to figure out first? Kate, why?
Because you know, like, how long it goes.
How?
20 seconds.
Why? So if it takes 6 seconds to come back, how long does it take to get to the top?
6 seconds.
To get to the top. If it takes 6 to do this, to get back to the ground, I'm saying
Oh, that's right.
3 seconds, because it's half of it. We're assuming no friction. When you get to physics, you're going to see like that's not actually true. It's not. On the way up and the way down is not perfect symmetry actually. But for these problems, it actually works out that there is perfect symmetry. So if you're doing a problem like this, I would do the second part first. You see that? Find the time it takes to get back to the ground and then have that. I mean, you could also find the time it takes to get to the top, but that involves using a parabola and the axis of symmetry and the vertex. And we're going to do that in chapter 7, but we haven't done it yet, so I wouldn't take that approach. Okay, but you can do it either way. Let me show you the way I'm mentioning. So number 16 says we have an initial speed of 80 feet per second. Our formula is given on the test. You don't have to memorize this. Negative 32.2. No, negative 16.1. Anybody have their notes?
I think it's in the book, actually.
It's not on this problem. Oh, yeah, it's probably on the previous page.
Yeah. Somewhere.
Jump over some. Yeah, here it is. Negative 16t plus vt. I do negative 16.1 because the exact value of gravity in feet per second is 32.2, and that happens to be half of that. That's where that comes from. Okay, in physics you'll learn it's 1/2 a. That's where the value comes in there. All right. The reasoning for the fact that they rounded to negative 16 is because it makes life very easy with the 80. It makes this factorable, 80 and 16. Parents teach you God bless you when somebody sneezes?
Well, I thought you called.
Oh, good point. All right, I'll allow it, even if it may be a lie. What's up? Yeah, Joanna.
Yeah, I was just going to ask where you negative 16.
So the formula is given on the test, and it was given in your notes this way. This is called the height function. This measures, ready? The height of an object at a given time. This is not a multiplication here. This is like f of x. This is f of x. Everybody look up, please, if you haven't seen this already. We went in class, but just so you know, the height of a function at a given time equals half of gravity, that's what that number is, it's given on the test, times t squared, which is the time it takes, plus the initial velocity times the time. Okay, that's what that means. The initial velocity, or speed, it says speed, but it's velocity, was given as 80 feet per second. So we go ahead and plug that in. And here's our height function for this problem. Okay? Now, at this point, what do we do? We're trying to find the time it takes to.
When height equals 0.
Good, Luke, there it is. Kate said earlier when it gets back to the ground. What's the height when it's at the ground? The height is 0. The height is 0 at the ground. Does that make sense? Okay, the other way to find the actual height at the top would be to take the actual axis of symmetry, and it's not something we've learned yet, so let's go with this approach. Well, what is your GCF? Please, right away, what's your GCF? What is it? I'll go with negative 16t. It could have been 8, but 16 goes into both also. And then don't forget t is in both, right? Why'd you take out the negative there, Annette? It makes sense. Why?
Because you just don't want to have a negative t.
Yeah, I agree. So that leaves this with just t. When you take out negative 16t from negative 16t squared, you're just left with negative 16t. And then if you take a 16 out of 80, it's a 5. 80 divided by 16 is 5. And that's going to be a negative 5 because we took out a negative 16, which switches the sign to negative there. Giving you an answer of t equals 5. And what's the other answer? Good.
5 seconds.
Yep. Very good, Max. Cannot be 0 seconds. Okay, cannot be 0 seconds. What is 0 seconds? That's before you've launched it. Makes sense. Where is the ball before you launch it? Where is it? Physically. On the ground at a height of 0. So at 0 seconds, it's on the ground. And after 5 seconds, it's still on the ground. So after 2.5 seconds now, it's at max height. So as a result, go back to your original function now. Go back to your function up here and plug in 2.5 for the function there. You want to know what the height is after 2.5 seconds, you evaluate the h function. You do h of 2.5. If you remember, that means plug it in. We did this earlier this year. So your 2.5 went in two locations. It went in here and it went in here. That will give you the height of the object after 2.5 seconds. Let's be quick with this answer. Somebody give it to me.
I'm still working it out.
The answer's 100. I beat you. Is it? All right. So we got 100 feet as our answer. That's the max height it comes out to be. Now, if we look quickly at, because we're going to run, oh no, it's an E day. I'm like, why are we so, I thought we were late. What time does the period usually end? You don't know the periods yet? Oh man, really? What is it normally?
9:25.
Normally 9:25. So it looks like we're about to end, but what kind of a day was today? So it's like 9:40. I'm like rushing. I was just about to run into 4.9 and fly through it. All right, let's relax. So you get the answer for the last one. It was 100. Does that make sense? No questions? What do we get?
160?
Was it 160? I hope I didn't screw it up. Because 80 times 2.5 is 200, right? And then negative 16 times 2.5 squared should be negative 100.
I thought it was negative 40 up here.
Did I do it wrong?
No, I got your answer.
What's negative 16 times 2.5 squared?
40. Oh, yeah, 40. Well, negative 40.
I got negative 100.
Did you square the 2.5 first, or did you square it after?
No, I didn't square it.
Square 2.5 and then multiply.
Yeah.
Okay. All right. 4.9. You want to jump to that, or do you want to go back to 4.7 and look at some more complicated ones with factoring? I can come up with a few of those real quick. Let me give you a function, one function from 4.7, and then we'll jump to 4.9. Does that work? We'll just do one of these because I want you to see at least the notation and stuff. I mean, you've seen it already, but I want you to be familiar for tomorrow. Let's say x to the fourth plus six x squared minus 40. And the question says the following. Where are you going? You can't start. What if I said, what's the value of the function at 2? You assume because it's 4.7, what are you just going to do? Set it equals 0. So let me stop you though, and I want you to hear the way it would be phrased, okay? The question could be asked as follows. Find the x-intercepts of this function, which means set the y value equal to 0. Or it could say, find the zeros of the function, which means set the function equal to 0. Or it could say, find the roots of this function when set equal to 0. That would be too easy to say. So there are three ways. You're looking for either the roots, you call them. Usually when it's an equation, you call it the roots. The zeros of the function or the x-intercepts of the function. Those are the same thing. Okay, go ahead. Sorry.
But you're always just setting to 0.
Later in your pre-calculus course, you'll do a lot more with functions than just set it equal to 0. But this is one of the biggest things. It's called root finding. One of the biggest lessons this year is about finding roots. You have like a couple main objectives, and that's one of those. Like at the end of the year, you need to know how to find roots. If you're struggling, start with this, please. This is the first step. The only way to get x to the fourth is by doing x squared and x squared. If it was x to the sixth, you would do x cubed, x cubed.
Is it plus 10 and then minus 4?
I got plus 10 and minus 4. I would agree.
Couldn't you make it x squared, x plus 2x?
Very good. So we'll then factor this one because it's difference of squares. Ooh, Luke just realized that. He's like, oh man. I didn't check my work. I jumped ahead and thought I was right off the bat. It's tough having you right next to you, isn't it? Yeah. It's fine. You're doing well. Don't forget to factor difference of two squares, please.
Does it change the answer when you do that?
Well, What does it do actually, guys? It gives you the answers. You'll still get the same answers, right? I'll show you why in a minute. What does this become though? Can we get an answer for that? So our answers are these. There's no real solution to the equation x squared equals negative 10. The solution is what we're going to talk about next in chapter 6. It's called imaginary. We'll see that actually in like 3 lessons into the next semester. Okay? So we'll get right into that. Now, to answer Luke's question, everybody take a look. If you forgot to factor this, you would have set this equal to 0, correct? Is that what you would have done?
Yeah.
You would have moved the 4 over, correct?
Yeah.
And then taken the square root. What you need to remember, and we haven't even gone over this yet, is that when you take a square root with an equation, the answer is plus or minus. Therefore, giving you answers of plus or minus 2. The exact same 2 answers we get up here is really here. So if you forgot to factor it, it's actually okay. You would still get the answer. See that? Okay, this is something that we haven't really gone over, but some of you probably seen this in middle school. That if you have a solution to an equation where it's squared and you take a square root, the root is positive or negative. Because what's negative 2 squared? What's negative 2 squared? So that solves this equation perfectly. And positive 2 squared also satisfies the equation. Both positive or negative 2 satisfies this equation. That's why there's 2 answers there. Do we all see that? All right. 4-9. Here's your inequality. Solve and graph the solution on a number line. Solve and graph the solution on a number line. Think about the steps I've given you and don't try to be a speed demon, because if you try to be a speed demon and do something that you think might work, you will actually miss part of the problem. So think about the instructions for these problems that you have to undergo. When you get your critical points, just raise your hand. Okay, you can put them back down. As soon as you get it, give me a little nod. Once you get your critical points, give me a nod. If you haven't done so already, I got the first 5. Get those critical points. Let me know when you get the critical points, please. Yeah, put them on a number line, test the regions, go through. I'm trying to keep track of everybody, and I also wanted to point something out, so I was going to stop you in the middle. It's all right, keep going if you want. Let me ask this question. How many critical points are there? Did everybody get 2? Be honest. Critical points. So sometimes I've seen this mistake. Let me just show you. Take a quick look up. Some students will think, and this I understand why, because it does make sense. They'll think there's x and x squared on both sides. So I could reduce by x, divide both sides by x, and you get this. And some students do that, and then you just get this as an answer. But that is not the correct answer, because this is only one of your critical points, isn't it? What was the other critical point? 0. And your answer will turn out that it's between really 0 and 3.5. Okay? So yeah, it's less than 3.5, I agree, less than or equal to, but it's also greater than or equal to 0. How do I know those are the critical points? So, let's go through this now. So again, this is not the correct way to do it, but my answer is on the right there. So let's go through the process. Move the 7x over, factor out x, factor this answer, get the solutions. We call these solutions But are they really solutions? No, they're critical points. You call them your boundary points, whatever you'd like to. Okay, those are your boundary points right there. Now the equation or the inequality says less than or equal to. If it said less than, how would my answer change on the number line? If it just said less than.
The circles would be open.
The open circles indicating that those endpoints are not included in the solution. But because 0 and 3.5 are included in the solution region, we shade those circles in. Then we test our regions. Take your region to the left of 0 in here, test -1. Where do you test it? Physically, where? Yeah, so in the, what do we call that? In the factored form. In the factored form. So if you test -1, this factor becomes negative. How about this factor? Is this whole thing negative or positive right here? This is going to become negative because it's going to be -2 minus 7 is -9. It's going to be -9 times -1. So all I care about is the fact that this region is negative. If I test the middle region, I'll test number 1. Plugging that in, this is positive, right? I'm sorry. I'm crazy. This is positive here. Testing this region right here, we're going to test the positive one here, making this positive. The positive one here, making this negative. This is going to be -5. +1 times -5 is negative. What do you think the last section is going to be? How do you know this? What did we do in class to prove this? So you watched the video that I recorded a while ago, right? So I didn't do what I'm doing now on that video. So watch what I'm going to do. What did I do in class? What did I have you guys do with this? Who remembers? To prove these regions made sense. Where did the negative, positive, negative come from? The graph, the parabola. We haven't done parabolas yet, but go to your graphing calculator and go ahead and do this real quick. Your roots will be 0 and 3.5. There's my roots on the graph. I don't care about the y values. I'm not even putting coordinates on the y-axis because they don't mean anything right now. Now, this sign right here indicates that the graph is above the axis. This sign indicates that it's below the axis. This sign indicates that the function is above the axis. That's all it actually means. So if you remember your shape of a parabola, either it looks like this, what I'm drawing now, where it opens up, or a parabola opens down. It's one or the other. In this case, just follow the directions. This says it's negative right here, so it means the function is below the x-axis. It means that the y value of the function is negative. Where are their negative y values? Right here. Positive y values are here. Remember, these are all positive y values, these are all negatives. This is really the y value of the function. So your graph looks like this. Okay? For those I know most of you were here in class. I know you were out. So does that make sense what I'm saying? Have you ever seen parabolic graphs in your previous math stuff yet? A little bit, yeah? Okay. So a parabola either looks like this always or looks like this. And since this is a quadratic, it's a parabola. Okay? Quadratic meaning x squared, therefore it's a parabola. Again, we haven't done this yet, so I didn't really go to it when I recorded that lesson originally, but I thought this was a good way to visualize what you're doing. And if you didn't know what this looked like, don't worry. Just go ahead in your calculator. You have a calculator just to practice it, and go to y1 max. Graph this in y1 right here. And for those who forgot from when we did this in class, graph this in y1. Whatever you have equal to 0 or less than 0, whatever it is, 2x squared minus 7x, put it in y1 and hit zoom 6. Zoom 6 always makes your graph standard from -10 to 10 and -10 to 10 on your axes. Other questions you want to go over? Let's do an example, Tristan. You wanted to do 5-1, 5-2?
Yeah.
Do one that's like complicated?
Fractions.
Sure. Take a look at this one. So this is similar to the one that we ended on the other day, yesterday actually, where you could take several roots. The reason I picked this is because it really does involve every rule that we've learned. You have a power to a power, distributing that power. You've got a quotient rule. You've got a product rule. You've got a negative rule. You've got a zero exponent rule. Every rule is in this one example. I'm going to step you through the way I would take an approach here personally. You can take any way you want. So if you want to jump ahead and do it, go ahead and do it. Check your answer again. My way to do this would be to simplify inside first. I think it's easier to do the inside first, then square at the end. 2/5 cannot be simplified. I'll leave that alone. If I look at this, I see that I've got a squared. This a to the negative 1. I'm going to take this a to the negative 1, bump it up to the numerator, and make it positive. Because that's what a negative exponent means. Make it positive and move it. If you forget that, look at your rules of where that came from. But just make it positive and move it. Cross this out now that you've moved it. And now you've got a squared and a to the first, which is a to the third in the numerator. Squared is still outside. Next.
You just add negative exponents to the top.
Remember, whenever it's a negative, make it positive and move it. So where was it start?
On the bottom,
So move it to the,
top,
if it was in the top, where would you have moved it?
down.
That's it. That's the only thing you got to remember for negative exponents. It's really easy if you remember that, okay? If the negative, though, remember Tristan, occurs out here, you could just make this positive and flip the entire fraction.
Just like
The entire thing. Because a negative exponent is a reciprocal law, meaning just flip it, okay? Now, what is anything to the 0 power automatically?
1.
So just cross off b to the 0 and put a 1 in its place. Well, there's a 5 down there already, so if you just think 1 times 5, well, that's just 5. So the 1 has no effect. We all see that. Next. Actually, let's do, some of you already solved it, right? I want to change it. Go back, I'm sorry. Make this a positive 3 in the numerator. Sorry. And I did that on purpose. I'm changing it on purpose. Make this a positive 3 here, please. Take a look, please, for those that already finished. Think about this as a positive 3. Would you use the quotient rule or just reduce? What did I instruct you in class? Just reduce. Because look, the quotient rule would say this. Let me follow you here. Let me show you. 3 minus 4, well, that gives me negative 1. And then you put b to the negative 1 here. But then where would that go if it was b to the negative 1 here? Where would it go? Back down below. So here's what I want you to visualize. Please, visualize. Look up. Think of this as b, b, b. Think of this as b, 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 b. There's 4 b's here and 3 here. Cancel 3 of these b's that are here with 3 of them that are here, leaving how many down here? 1. Does everybody see what I'm doing? It makes life so much easier to avoid the negative exponents. Just simply reduce. Again, think of this as b, b, b. Think of this as b, 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 b. Cancel 3 of these with these 3, leaving you 1 behind. All right? So this is my answer? No. I have to still square everything. What do I get when I square everything, Bridge?
You get 4 a to the 6th over
8 to the
a to the 6th
6th.
and 25
Very good. Yeah.
So is there like, will you get points taken off if you left at like 2 squared or like 5 squared?
Technically, no, but you should square it. And honestly, this is going to be a multiple choice, most likely. I might give you something like this as a short answer, but you'll definitely have this as a multiple choice. Because these are such great multiple choice questions on SATs, every one. Because it's so easy to make one simple mistake, and you get a whole different answer, and then your answer shows up as a choice, and what do naturally? Oh, I got it right. You know what I'm saying? And they look for those mistakes. On the SAT, what are the common mistakes? It'd be to like maybe put the B up here, or instead of making this a to the 6th, make this a to the 5th, because students will do 3 plus 2 and make that a 5. 1 plus 2, they'll make that a 3. You see what I'm saying? So all the common mistakes that you can think of are the other choices. So although on the test you might be like, dang, I'm doing well, every one of my answers showed up, you got to go back and check your work. And a lot of you sometimes don't do a good job of that. There are careless mistakes that show up, and 2 points on a multiple choice is like 4 to 5 points percentage-wise on the test, right? What's due Monday?
project.
Project. 5152 due Tuesday. Okay? I'll put this